All right, in this video, I'm going to go over test one practice set. Okay, and I'm going to go over chapter two problems. Okay, in the next video, I'm going to cover chapter three problems, it's practice problems. So see, chapter two, section seven, problem one. That's the first problem in the test one practice set. So a cell phone user select an app to download, and then each of 10 apps is independently selected with probability 0.25. So see that independently selected. So then each event, um, I mean, the selecting each app going to be independent, right? So and then see question A. I mean, round your answers to two decimal places. So here's the example, right? 98.76. Keep in mind that. So if each of the first nine apps are already downloaded, right? Okay. So nine events are already happened, right? So what is the probability that the last app is downloaded, right? And then see, let me just read through questions, and then um, I'm gonna give solutions for each problems. In sketch paper. So B, what is the probability that the cell phone user download at least three apps? So by the way, in the question A, you see that here. Uh, first nine apps already downloaded, and then we need to figure out probability that last app is downloaded. Then what? We need to apply the conditional probability. Okay, set event A denote is denoted by first nine apps are downloaded, and then event B is denoted by the last app downloaded, and then we had to find the probability that A B bar A. Okay, and the B um, the what is the probability that cell phone is user download at least three apps? See that? In these three apps, then we have to use a rule for complement rule. Okay. So now, then what is the probability that app one or two is downloaded? That we have to use addition rule. Probability that A or B. Okay, let me go over this one in the sketch paper. Give me a second. All right, chapter 2.7, problem number one, and question A. Um, we say, I mean, the let's say event A, the denoted by, I mean, it's denote the first nine apps are downloaded. Okay, so it's the set of the first nine apps are downloaded. Okay, so now then let's say B is the denote the last app is downloaded. Okay, so you don't have to use the set notation, but let me use it. Now then what? The key in mind is event A and B must be independent because the problem says that each of 10 apps is independently selected. Okay, so now we will need to figure out probability that B bar A because A event A is already occurred, right? So we got to use the contingent probability. But since the two events are independent, so this is equal to probability B. Okay. The problem says that what the probability that what the each event selected is going to be 0.25. So this is going to be 0.25, right? That's probably easy, right? The question B. So what is the probability that a cell phone user download at least three apps? Okay. So at least three apps, right? Then the we use this. Let's say first one denote the let X denote the number of apps that are downloaded. Okay, the number of apps. Okay, and then they are downloaded. Okay, they are downloaded. Then we need to figure out probability that X is greater than or equals 3, isn't it? Because at least 3, right? So then what? X can be what? 3, 4, 5, 6 through the 10, right? That's too much. So now we're going to use a Rupert complement. So this is equal to 1 minus probability that what? X is less than 3. But a is equal to 1 minus, right? Probability that x equals what? 0. Okay. The x equals 0 union x equals 1, isn't it? Union x equals 2, is it? You don't have to use that bracket, but okay, just in case. Okay. So this is what we have to apply the addition rule, right? Okay. But you know what? The this is equal to 1 minus probability that the these each event are what independent. So the probability that x equals 0 intersect with x equals 1. I mean, intersection between two events going to be 0 because each events are independent. So this is equal to actually what? X equals 0 plus probability that x equals 1 plus probability that x equals 2. Okay, we can say that. I mean, so I mean, do you remember that probability that A union B is what in a textbook? And I mean, addition rule is going to be probability A plus probability B and then minus probability A intersection B, isn't it? That's the addition rule. But two events are what the not in yeah, it's just not because of independent, but two events are actual. I mean, the events are mutually exclusive. Okay, I mean, so look at this. Applying this in the addition rule here, then we have to think about this one: x equals 0 intersection, and then x equals 1, and then probability that x equals 1 intersection x equals 2, the probability that x equals 0 intersection x equals 2, isn't it? But you see that here, these are doesn't make sense. See, because the X denote the one number of apps downloaded, and then probable that 0 apps are downloaded at the same time. For one, apps is downloaded. That doesn't make sense. It never happened, right? Two events will never happen, right? So these are so it means that what that actual random variable, right? This one random variable. This is mutually exclusive, right? So now we're gonna do we got this one, then what? Each one is what 0.25, right? I mean that is equal to 1 minus, okay, x equals 0. But also we have to think about the which app is downloaded. I mean, for x equals 1, which app is downloaded? First app, second app? There is order, right? There is the each app has been labeled, right? There is a number for each app, so we have to think about the order, right? So now then what that means, we have to select 0 10 times 1 minus, isn't it, 0.25 to the 10th power. That's a probability that 0 apps is downloaded out of 10, plus probability x equals 1 going to be 10 1, and then 0.25, and then 1 minus 0.25 9th power. Okay, so now you see that here, then we haven't seen this kind of formula in actually chapter 3, right? So but this is a binomial distribution, similar to a binomial distribution, right? So now plus 10 2, and then 0.25 square times 1 minus 0.25 to the 8th power close. Okay, you see? Okay, so now see, here's a b. This is b right there. Okay, so now see. All right, so then how can you calculate this one? Yeah, you can use a calculator. All right, but let me use the integration function in a calculator. Okay, so now then, so because since we learned about the binomial distribution chapter 3, even though this problem is the problem in chapter 2, we can use the formula the binomial distribution where we learn the what we learned in chapter 3, right? So in the calculator, so we go to the distribution. Oh, by the way, you know where's distribution? Right there. Okay, see that? So press second, press variables. So you see binomial PDF, right? Okay. Yeah, definitely you can use binomial CDF because cumulative density function, right? So because this is CDF, right? That's a CDF, right? So this is equal to what? That is nothing but probability that x is less than or equals 2, right? So now then, you can use the, let me use a binomial CDF. Well, let me use binomial PDF to figure out the each probability. Okay, this one, this one, this one. And then let's figure out the, let me use a binomial CDF. Okay. So now, using the binomial PDF, trier is a 10, probably 0.25, and the x value, in this case, is 0 right here. 0, 0. Paste. So we got 0.05 6313, right? Okay. So now this is going to be, that is equal to 0.0563. Here, do not the round the round up. Okay, do not the round over round. Do not round the that decimal. Okay, what you have to um, copy the full decimals of that number here. Okay, for each probability, adding them up, and then subtract the that number from 1, you got result, and then you have to round. Keep in mind this. So now next one is the for the second one, probably the x equals 1, which is this. Okay, it's going to be let's see. Use the binomial PDF. Okay, 10.25. Now this is not 0. X value must be 1. Okay, so we got 0.18. Okay, let me finish writing that decimal first. 35631 okay, plus 0.1877117157. Okay, and then plus next one is the binomial PDF, and then x the trier 10 point probability is 0.25, x value is not 1 but 2, so we got 0.2815675,735. Okay, now we're adding them up. So now I'm not going to add these three numbers by hand. Okay, I'll just use calculator. Okay, this one plus second number plus the last number. So we got 0.52599, and then we subtract that number from 1, right? 1 minus that number. So we got 0.4744. Now we round, okay, to get the 2 decimal places. So which is 0.47, right? This is 1 minus. Sorry, here's type of 1 minus. This is equal to 0.247. Okay. Now the easiest way is this. We do 1 minus in calculator, 1 minus, and then using the binomial CDF, we figure out this, which is this. So binomial CDF, and then trier is 10, probably 0.25, and the x value is 2. So we got to say the 0.24744. Much easier than that way, right? Okay. So now so key point is in the problem B here, once we define the random variable of x as the number of apps, then that probability, this one is actually what that probability is the probability of the binomial distribution. Okay, keep in mind this. So the last question C in problem the one, okay, C. Question C. Let A denote the what is the probability that FA over 2 is downloaded? So now we need to figure out the let's say let's say C, okay? Let C denote the app 1 is downloaded, okay? Okay, app 1. So this there app 1, 2, 3, 4 is makes sense, okay? App 1. So app 1 means what? 1 is the the label of the app, which means that this is the first app, okay? So now the lab 1, say lab 1 is downloaded, okay? Then let's say D denote the app 2, okay? App 2 is downloaded. Right? Well, now then we need to figure out probability that C union D, right? Okay. So now see what keep in mind is what the then this is going to be probability by the Asian rule. This is probability C plus probability D, right? Okay, minus probability C intersection D. Okay. So now see C and what? C and D here. Keep in mind is do not confuse with the C and D with the that random variable x. Here random variable x is a number of apps, and then C denote the what? The app 1 is download, D denote the app 2 is download. So this is not the problem of a binomial distribution. Okay, do not confuse with the problem question B and question C. Okay, and then now is C and D are what? Independent, right? So now if you do two events are independent, then P of C and D becomes what? Probability C times probability D. Okay, when you select the app, it's impossible to select the what when you select the you select the one app, it's not possible to select the both apps, app 1 and app 2. It's impossible, right? Okay, then probability that what you select the C and D, that will becomes, I mean, assuming that you in this you select the two more than two apps, the probability that you select the C like app 1 and app 2 going to be just P of C times P of D, because the what the probability you select the app 1 will not be impacted by the you select the app 2, or so vice versa. Okay, it's vice versa. Okay, so now the P of C times P of D. Key minus two events are independent, then P of C intersection D is equal to P of C times P of D. Key minus. Now this is 0.25. This is 0.25, and then 0.25, 0.25, right? Equally likely. Remember that. So this is equal to 0.25 plus 0.25 minus 0.25 squared, right? Okay, so that is equal to 0.44. Okay, so that's the chapter 2 section chapter 2.7 problem 1 in our test 1 practice problems. Let's see the next problem. Chapter 2.7 problem. It's actually the second problem, but it's the problem number is 3. Okay, suppose a 7% discount is independently applied to web orders for clothing with a probability 0.2. It's question A. What is the probability that the first discount is applied to the fifth order? Okay, so I guess the guy just keep ordering through online, okay, multiple times. Okay, so now then probability that you get the guy get the 7% discount is 0.2. Okay, then think about this. The guy just order did first order. Okay, the what the probability that that first order, I mean, assume that this guy just ordered the the order 5 times. Okay, so now then probability that the guy get the discount and first order is 0.2, second order is 0.2, third order 0.2, because the problem says about independently. Okay, so right, so now the then so we gonna what use the what, if two events are independent, then what let's say two events A and B are independent, then probability A intersection B is equal to P of A times P of B, right? So what does the independence means? That the probability that in this example the guy get the discount, sample discount in first order will not be will not affect on the second order to get discount, sample discount. Okay, so now question B. So what is the probability that at least one order in the next 5 receives the discount? So you see the at least, then you're gonna use a rule for complement. So let's go over those problems in Sky's paper. So now we're gonna do CA. This is chapter 2.7. Okay, and the problem extra 3. Okay, but this is test 1 practice set problem number 2. Okay, but title of the problem is this. So now the question A. So we're gonna do let's say A is the denote the discount is applied. Okay, so that denote the okay. And let's say B is the discount is not applied. Okay, but we know the probability of A, which is what, 0.2. The problem says that, right? 0.2. But you know what? Probability of A what plus B gonna be should be 1, right? Think about this. And for each order, probability that on in the order in on order, the probability that the sample discount is applied, or I mean the probability it should either it should be either sample discount is applied or not applied, right? So probability that discount is applied plus probability that discount is not applied for once every single the discount must be 1. Okay, so now this is going to be what, 1. We know that P of A is 0.2, so P of B is going to be what, 0.8. Okay, so this is going to be 0.8. Now we're going to do, so we need to figure out probability that what, the question A is what is the probability that first discount is applied to the 5th order, right? Okay, so now then the first discount is applied to the 5th order. It means that up to 4th order discount has not been applied, right? So P of B, right, and then union intersection, right? Okay, B, B, B. So that one represent that first B represent the what discount is not applied in the first order, and then second B represent the discount is not applied in the second order, third order, and the first order. Now, because these event must be the what should be happen sequentially, right? Sequence. So this is the last one, we can get A, right? So now this is equal to, you see, each event, all events must be what? Independent. So this is equal to P of B times P of B times P of B times P of B times P of A. Okay, so this is equal to 0.8 to the 4th power times 0.2. Okay, that's going to be 0.082. Okay, so now next one, question B. Let's see, what is the probability that at least one order in the next 5 receives the discount? So then think about this. In this one order, probably in this one order, in the next 5 receive the discount. It means that then we're gonna do this. The using the rule for complement, we think about the no order receive discount. The next 5 receive. So that's gonna be probably that what n the B intersection B intersection B intersection B, right? Intersection 1, 2, 3, 4, 5. Okay, and that's gonna be the the guy didn't get any discount. I mean, didn't get discount for 5 orders, right? And then we subtract that probably from 1. Okay, let's see. Then what? That is the what? That means what? That means the probability that at least one order in the next 5 receive the discount. Okay, so this is going to be 1 minus probability of B to the fifth power, right? Which is the 1 minus 0.8 to the fifth power, right? So this is going to be 0.672. Okay. All right, let's see next problem. Chapter 2, Section 8, problem number 1. An article in the Transportation Research Part E journal considered a way of re-establishing the connectivity of road networks after a natural disaster, earthquake. So estimates the probability of a randomly chosen road being under light debris, moderate debris, and heavy debris conditions after different disaster magnitude are shown in the following table. So disaster magnitude is equally likely to be low, moderate, or high. So it's in the table right there. Okay, so you see light debris and moderate debris and heavy debris and disaster. This is level of the disaster magnitude: low, moderate, and high. Okay. So now, I think a 300. See that 300. The rows are observed, right? So it's question. Given that, oh, it's given that, oh, then definitely this problem is about condition probability, right? Given that roads had light debris after an earthquake, okay, so low light debris, that event is already occurred. So what is the condition probability that disaster magnitude was high? So make this magnitude higher is right here. Okay. So give me a second. So in these problems, this is the chapter 2.8 and the problem number 1. So let's say I the high. Okay, so let's say H disaster magnitude HDM. Okay, HDM represent the high disaster magnitude. Okay, and then light debris. Okay, let's say LD. Okay, this is a light debris. Oops, it's a typo. Debris. Okay. So then we're gonna figure out the probability that HDM, that event HDM happened given that LD already occurred. Then what's the definition of condition probability? This is gonna be, I'm gonna use definition of condition probability, which is the HDM. Oops, why does it keep writing M first? Intersection LD, right? Divided by probability of LD. Why do I wanna use the formula? I mean, definition of condition probability, because because table is given, right? The number of the uh, number of rows for each conditions are given in the table. So it's easy to figure out the top and bottom. So now you see, we need to find out the number of rows, okay, uh, having the both conditions, HDM and LD, which is the 30 out of 300 rows, right? That's the probability of this one, HDM intersected with LD. Okay, so road is under light debris, and then the let's see, and then got the high disaster magnitude is 30 out of 300. Divided by probability LD going to be the 160 road are under light debris out of 300 road. That's the probability of LD, light debris. Okay, see both numerator and denominator has the same denominator. It's 300, 300. So cancel them out. So we got 300 is 160. Okay, so I mean definitely you need to figure out the you need to write this one as the decimal number, decimal expression. Okay, I think this is 0.19. Okay, so that's the quite easy, right? So now let's move to the next problem. What's the next problems? The This is visual problem, chapter 2, section A, problem number 3. So consider endothermic reactions given below. So see a table right there. Final temperature conditions 200 listed 260K and then 271K, 274K, and then heat observed the calorie. So the 11, 44, 56 the below target, and the above target listed 41, 16, 36. Use Bayes theorems to calculate the probability that a reaction's final temperature is 271K or less. And then given that the heat observed is above target, round your answer to 3 decimal places. Let's see. Okay. Probably we don't have to use a Bayes theorem, but yeah, so let me give 2 ways to solve the problems with Bayes theorem or without using Bayes theorem. Okay. All right. So in these problems, let me see. So this is chapter 2.8, problem number 3. Okay. So first of all, let's say A denote the event that reaction final temperature is 271K or less. Okay. Denote the 271K or less. Okay. And then let's say event B denote the heat observed is above target. Okay. So now what are you gonna do? We need to find the probability that what B A, right? C given that B. That's it. So then yeah, what's the definition of the what of condition probability, which is this is a P of A intersection B, right? Over P of B. Is it? Okay. So now that is equal to yeah, we can find the P of A intersection B and the P of B. I mean, you see, give me a second. Yeah, see the problem right here. So A intersection B gonna be what? 41 plus 16, right? Divided by total number of the reactions. Okay, I think 11 plus 44 plus 56 plus 41 plus 16 plus 36, 204. So, and the 41 plus 16 is 57. So 50, give me a second. So you see that here 41 plus 16, that's the number of the reactions above target, and final temperature is greater less than or equals 271. Okay, so that's 57 over 204. That's going to P of A intersection B, and the P of B is what? P of B is the 41 plus 16 plus 36 over 204. That's going to be P of B, right? So in this problem, you don't have to use a Bayes theorem, but so I'm going to find the answer first without using Bayes theorem, and then I'll solve again this problem again using Bayes theorem. Okay. So all right. So now this is going to be 57, right? 57 over 204 over 93 divided by 204. So which is 57 over 93. Okay. It's going to be 0.613. Okay, because the problem says that round the answer to 3 decimal places. Okay, so now then this is equal to now the method 1, the second method. This is equal to P of A in the intersection B. So let's see, let me figure out the two before applying the Bayes theorem. Let's figure out the set event A and B in the Venn diagram. Okay, so now then we have think about two case. I mean that um all the reactions can be divided by two groups, or B and B prime, right? Above target, below target, right? Okay, and then let's say this is event A, which is the set of the reactions whose final temperature is less than or equal to 171 K. Okay, so now we want to figure out was, I mean, this is B intersection A, right? And then this is B prime intersection A right here. And then we need to figure out this one. And then starting from definition of conditional probability, which is this, A is equal to, now P of A intersection B can be expressed in terms of conditional probability, right? P of B, oh, let's see, let me use P of A, right? P of A, okay, P of A times P of B bar A, right? Okay, P bar A. So now over P of B can be expressed in terms of this one and this one. I mean, you see? Okay, so I mean, give me a second to understand that. This part and this part. Okay, so that the blue the reason gonna be probability of what? Gonna be P of B intersection A prime, right? And that region colored by red is a P of B intersection A, is it? So the bottom one going to be P of B intersection A plus probability that B of intersection A prime. We see that definitely we see that two events, B intersection A prime and B intersection A are what? The mutually exclusive, right? So can be expressed as like this. Now this is equal to, I just copy top one and the bottom one. We express those two intersection in terms of conditional probability, which is the P of B A times P of B bar A plus P of A prime times P of B bar A prime. Okay, and then we're going to figure out all the each probability. Okay, I think is, yeah. So then P of A going to be what? So P of A, what is A? A is event A is what? The number of probable reaction. Final temperature is less than or equal to 271 K. Okay, so it's going to be 11 plus 41 is, give me a second, 11 plus 44 plus 41 plus 16 divided by 204. That's a P of A. Okay, times, ooh. And then now next one is what? P of B bar A. So event A is already occurred, and then we need to find out number of reactions whose heat observed is above target. Okay, which is the 41 plus 16, which is the 41 plus 16, yeah, times 41 plus 16 divided by, okay, A is already occurred. So it means that final temperatures, what? I mean, temperature is less than or equals 271 K. So total number of the reaction will be reduced, okay, which is the 11 plus 44 plus, okay, 41 plus 16. Okay, that's the numerator. Divide by, I need more space. But the bottom one, let me copy this one, okay, in the next sketch paper. So P of A times P of B bar A. Give me a second.